Introduction to Factor World. Hi, I'm Ian Roberts and I'm here to introduce you to Factor World. Factor World contains topics which have been around and studied for at least 2,500 years. And when they were studied, it was done by the Greeks just because number was an elementary part of life which they closely related with religion. And for a long time, number theory was seen as the queen of mathematics, but not very useful. Nowadays, every single person who I know uses number theory almost every day, because every time we use a phone or make a electronic transaction, we need some security put in place. And most of the ways that you set up security between two parties who don't know one another over a line, like a line on the internet which anyone can access, something has to be done to set up that security, and the way it's done is what's called using a public key or a private key. You can look that up, and there's an algorithm called the RSA algorithm which is very commonly used, and the RSA algorithm is totally based upon the use of prime numbers. So nowadays, number theory, just in that one case, is one of the most used parts of mathematics. The material is written not for you to get answers, but for you to start exploring and thinking. It was written so you start to learn some of the basic things that we just find so useful in mathematics. And from that exploration and you learning it yourself, hopefully you have a much better understanding and appreciation of it than just doing some silly, boring textbook examples. Every positive integer greater than 1 can always be written as a product of prime numbers, and you need to find out the proper definition of prime numbers. You need to know how to get prime numbers. A simple hand way of doing it is called the sieve of Eratosthenes, and that goes back almost 2,500 years, and that will be illustrated separately. You can always look up a table of prime numbers on the web, but I think seeing the sieve for the first time is a good idea, and it'll give you an appreciation that what's good for doing it by hand will in the end turn out to be a very inefficient way of doing it for large numbers. When the RSA algorithm is used, you might be using numbers which have 200 digits. And it's impossible, even with fast computers, to do a lot of the calculations that are required around that, especially to break the code. So the idea of what we can do by hand and the idea of what we can do by smart algorithms is quite different. And doing it by hand will give you some appreciation of the difficulty. On the other hand, the actual work you're asked to do is very straightforward, and if I was writing the curriculum, it's the sort of thing that everybody in year 6 would be doing before you're doing work on arithmetic with fractions, because so many things working with fractions, for example, can be made much easier by knowing the things that you'll learn by going through this little unit of work. So good luck with it. Explore. There is no end point for this. It is something that's been used in Japan. We have material generated by one particular Japanese student which will be available, and it is still a point of interest for myself and several other mathematicians, and we're still exploring this topic. So the top end of this topic is still totally unknown, and we're still exploring. At this stage, play, learn some stuff. Don't spend endless hours just doing boring routine examples. The examples are there to help you get an understanding, to get a feeling. See if you can start thinking about some generalizations. One of the most important things you'll learn is how to work out how many different factors a number has in a very simple way. So really concentrate on that. It's one of the most useful things that I know. Good luck, have fun, and look at the other resources that will be made available to you. Bye.